Hi, I'm Mike Thompson, and in this video I'm going to show you how to use the Sporty's electronic E6B flight computer. Now the learning curve with this thing is pretty steep, but I'm going to flatten it out for you a little bit. I suppose that maybe it's not as steep as this thing, but once you've been comfortable with this for 20 years, switching over to this can be a little bit tricky. It is approved for FAA tests, and I recently used it to fly through my advanced ground instructor exam. So let's start from the beginning. A very good place to start. This flight computer uses 3 AAA batteries. And once you put them in, turn the computer on. It's the power button symbol here in the bottom left corner. Removing the batteries resets the computer and its clock. Now the first thing we should probably do is set the clock. So we're going to press the big clock function key. You can see here now we've got Zulu, home, and local. To set the clock, we're going to activate the secondary functions, which are in yellow above most of the keys. To activate the secondary functions, we're going to press the yellow convert function key over here on the left. So we're going to hit convert, then clock, because that's actually going to activate that little alternate set in yellow that's above the clock. Then the first digit starts blinking so that we can enter a number. And we'll set this to the correct time. The hours for Zulu are flashing first, so we'll just punch this in. It's 16:37:15 Zulu right now, so I'm going to push 16:37:15. Then I can press the down arrow to set my home clock, which is 5 hours behind Zulu, so I'll put 11. Hitting the up and down arrow keys navigates around the clock, and notice how the minutes and seconds for home and local are synced up with the Zulu clock. So once you put in the Zulu time, you only need to put in the hours for home and local. Times are always entered using the colon in hour, minute, second format. Hitting the clock again at any time sets it, and it'll stop flashing. You can do basic math on this pretty much at any time. If you're in a menu like we were in the clock now, you'll be able to do math at the top. So let's do 16 over 3.5. We use the equals button for math, never the enter button. You can also do math before you enter any menu. To clear the current function, just hit another menu function and you'll get a flashing menu function. But you'll also get a 0 and a decimal point. This lets you know that it's ready to do some math. I can jump between menus, and that 0 is always there. There will also be a 0 on the screen when you first start up, and you can do math there. So 25.6 times 13. Then you hit equals, not enter when doing math. 332.8. If you happen to be in one of the menu functions and need to do math that's not related to one of your function inputs, then you can just hit one of the function keys other than timer or clock, and it will clear your screen, and you'll see that 0 come up again, and now you can do some math. Remember to hit equals, not enter. This computer only does the 4 basic math functions. It does them quite well, but that's all it does. It does math with times too. Times are always entered in hours, minutes, seconds. Want to find the time of your flight? Well, you know when you took off and when you arrived, so let's do some subtraction. We arrived at 16:12:18, and we took off at exactly 13:05. Hit equals, and you can see that our flight was 3 hours, 7 minutes, and 18 seconds. But now let's convert that to a decimal for our logbook, shall we? Hit the convert button, and then the X button, which has the hours, minutes, seconds to hours, and now it's 3.12167 hours. And we can convert it back should we need to by hitting convert and then the number 6 key. Pretty easy, isn't it? The next thing you probably want to do is know how to activate the backlight, because it's dark by now. So you hit convert and then either the up or the down arrow, depending on whether you want the light on or off. If the light's already off, you can't make it any more off, so hit the up button, and it will stay there until you tell it otherwise. Let's plan a flight, shall we? Let's do our weight and balance first, because that's probably not going to change as fast as the weather will. So push the function key that says WT/BAL. Obviously that means weight and balance. And when you enter a function, it's going to flash a couple of options at you. And the active option is the one that's flashing. In this case, it's flashing us the weight/arm option. We can press the up or down arrow to change the option. And so the middle option, you can do it by weights or moments, or in that last option, you can do it by a percentage of your mean aerodynamic chord. But that's usually only reserved for jets. So I'm going to keep scrolling, and we're going to go to weight and arm. Enter. Now inside the menus, it's going to flash what it's asking for, and it needs a weight first. It's also going to keep a running total, so you do have to keep track of what you've already done. So let's say our plane has an empty weight of 1560. So we're going to punch in 1560, and we're going to hit enter. Now it's asking us for the arm, and this is the length from the datum. Let's say it's 84 inches. And now it's asking for a reduction factor. This is the number that's going to divide by when we're dealing with really large moments. For small aircraft, we can leave this at 1. 100 and 1,000 are also common numbers. So we can hit enter one more time, and it does all the math for this first weight. Our moment's 131,040, and you can see that our gross weight down there at the bottom is 1560. Now we can hit enter again to go back to the top weight. It'll let you do math on any of these lines as well. So 200 pounds for a pilot plus 150 pounds for a co-pilot, press equal, and you can see it says 350. You could also do this for fuel. Gallons times weight per gallon and equals. Now we can enter and go down to our arm. The front seats are located at 73 inches. Enter, and you can see it recomputed our moment and our CG and our gross weight. So let's add some baggage. Enter. So back on the weight line, we will put 50, and we will hit enter. And this is 120 inches. Enter. It updates our moments, our CG, our gross weight. But we can also subtract, and this is really handy. So let's hit enter to get back to our weight line. Our co-pilot's not going, so we can put in minus 150 by hitting 150, and then the little minus button, which is over here, under the convert. You have to put in your numbers first, then hit the negative sign. Hit it, and the little minus appears next to the 150. We hit enter to go down to your arm, and remember that the front seats were 73, so we put in 73. We hit enter, and you'll see that our gross weight drops, our moment drops, and our CG recomputes. So that's how you do weight and balance with the arms. If we wanted to do the moments, it's very similar. So go back to the weight and balance button, hit down until the weight moment's flashing, and then hit enter. It's going to ask us for our weight, and we'll put 1560. We'll hit enter. We'll go down to the moment instead of an arm. And remember, it's always flashing what it's asking for. So you punch in a moment, then a reference factor. It's going to be 100 this time, because moments for Cessnas and things are usually divided by 100, because remember, these moments are really big numbers. So we'll hit enter one more time, and you can see that it computed our CG and our gross weight. And so we hit enter again, and we can start adding or subtracting our weights and our moments. Pretty slick, huh? Now, if we wanted to do it by percent mean aerodynamic chord, it'd be very similar, so we're going to skip that. So now let's plan our flight. We're going to need to find our airspeeds and ground speeds, but first we need to find what our actual pressure and density altitudes are going to be so that we can plan for speeds. So I'm going to click the heading ground speed PDL button here in the top left, and we're going to scroll down to PD alt, and we're going to punch in some numbers. Let's fly at 5,500 feet. So 5500, enter. Altimeter is 29.74, enter. Make sure to include that decimal point on altimeter or else you're going to get some ridiculous numbers. Temperature's in Celsius, and it's minus 10. So hit 10, then the little minus plus button. And see a minus appears right here. So hit enter, and it's going to flash your pressure and density altitudes. 5667 and 3962. Now we can go get some speeds, and the great thing about this calculator is that it's going to remember the last things you put in, so you don't have to remember them. So press the speed function, and let's go down to ACT, actual true airspeed. Hit enter, and notice it's flashing that pressure altitude at us. And that's the pressure altitude that we just calculated in the step before. Neat, huh? So hit enter, and you can see now it wants temperature. This temperature is not necessarily the same as the last one, but let's pretend it is. Minus 10. Enter. Okay, now this is a little sticky point with me. Everything in this computer is calculated in calibrated airspeed, which we would normally mean indicated airspeed. You will not see indicated airspeed anywhere in this flight computer. It's always going to say CAS. But once you get over that, you're fine. Enter. And now it flashes your true airspeed and even a Mach number. Ha, I wish. And you get a density altitude. So we can go back to the speed function button, and you can see that there's a plan Mach number, actual Mach number, and stuff at the bottom, but we're going to skip those. We're going to go to plan true airspeed. It brought in our pressure altitude, enter. It brought in our temperature, enter. And it brought in our calibrated airspeed or indicated airspeed, enter. And you can see it spits out a slightly different true airspeed. We probably want a ground speed though, don't we? Now it's not in the speed function. Well, it is, but that's not the ground speed I'm talking about. I'm talking about the ground speed that we're planning for before we ever even take off. The one that's going to tell us our expected leg times. So let's go to the top left button here, heading ground speed, pressure, density, altitude. There are only two options when you press this button. You've got heading ground speed, or you can arrow down to pressure, density, altitude. If you click on heading ground speed, it's going to flash wind direction at you. The wind is coming from 060 at 25, so enter, enter. You're going to fly course 270, enter. True airspeed is brought in from our previous calculation, enter. And we can hit enter, and you can see that it spits out our ground speed, and it even gives us a heading, our wind correction angle. Nice. Okay, we've finished with the top left button, but what about this wind button right below it? Well, let's hit that. It's going to flash wind at us, and we're going to press enter. It brought in our course from before, enter. It brought in our true airspeed, enter. It brought in our ground speed, enter. And heading, enter. And so what it spits out is what's flashing at us. It's telling us the wind direction and the wind speed. This is for when we're already in flight and we're trying to find an unknown wind, or on a test, if we care. Our instruments and GPS are going to tell us these other four things, and so it spits out the wind speed and direction. Let's go back to the wind function. We're going to arrow down to cross our headwind and hit enter. It brings in our wind direction quite precisely. We hit enter, and it brings in a very precise wind speed, enter. And now we pick which runway we'd like. Let's go with runway 3. So you can type 03 or just 3, and then hit enter. It flashes our crosswind and our headwind component at us. Headwind has a minus because it's pushing against us, so it is in fact a headwind. Let's hit enter to get back to our runway, and let's put in runway 21 and hit enter. You can see that our headwind is no longer negative, so it's a tailwind, and our crosswind is now negative, so that it's actually from our left this time. Press the wind function button, and let's arrow down and hit Cloudbase. I don't know why Cloudbase is in the wind menu, but it is. It's asking for our outside air temperature in degrees Celsius. 20, enter. And it's asking for the dew point of 12, enter. And then it flashes a cloud AGL at us of 3,200. We can also input Fahrenheit numbers and convert them. So we can punch in 59, convert F to C, and 37, convert F to C, and it gives us the AGL of our cloud base. So that's all for the wind button. A few things on your flight will be required, and you're probably going to want to know what these are. So push the required function. Let's start with fuel. Enter. It's going to ask you for a time. Let's say 27 minutes. Enter. The times are always entered in hours, minutes, and seconds using the colon button on the left side. So to enter 27 minutes, you're going to push 0:27, and you can just leave it there because it looks right. Now hit enter to get down to the next input. FPH is fuel per hour, your fuel burn. 1:1, enter. You can see at the bottom that tells you that you need 5 gallons of fuel, which makes sense, right? 27 minutes is slightly less than half an hour, and 5 is slightly less than half of 11. So let's go back to the required button and go down to climb. Enter. It says MCLM. This is your minimum climb gradient, and departures will sometimes specify this. This will be that feet per nautical mile thing. So it's 700. Your ground speed was brought in from before. Look at that. But you could put in a different number here if you needed to at this point, because maybe you're now on a different plane under different conditions, and all those old things don't apply anymore. Our ground speed this time will be 93. We hit enter and see that our minimum rate of climb, MROC, is 1,085 feet a minute. Happens to be 11.5%, and that's probably doable because we're pretty light today. So if we go back to the required function and scroll down to descent, we'll get something similar. It's going to ask us for our ground speed, which is 93, enter. Our altitude was 5,500, enter. Our crossing altitude will be 8,000. And our fixed distance is 12 miles away, enter. And it flashes a required rate of descent of minus 322. It's negative because we're actually climbing. If you started at 5,500 and you end up at 8,000, well, that's not a descent. So that's why it's negative. So it works both ways. So let's go back to our required button and arrow down to true airspeed, TAS, and hit enter. It's asking us for our wind direction, which it pulled in from before. Enter. Then it wants the wind speed. Enter. Enter course. Ground speed. Enter. After we enter for the last time, it's going to flash a true airspeed and heading at us. You'd use this if you needed to know what speed to fly to go a certain distance in a certain time. This is a popular test question. To find our required calibrated airspeed, or indicated airspeed, we'll use the required function and arrow down to CAS. We can input our pressure altitude and our temperature. Remember, if it's negative, you type in the number first, then hit the little negative button on the left side of the computer. We'll hit enter and we'll input our true airspeed. And it's going to give us our indicated airspeed, then our calibrated airspeed. It's also going to give us a Mach number and density altitude. If you didn't have a true airspeed indicated on your airspeed indicator, you'd do this step after you found the required true airspeed from the previous step. Then you'd set your airspeed indicator at the calibrated airspeed shown here. Now your plane will be on time, so you can get to work by 9 and start your slaving job and get your pay. Let's play with the speed button a bit. So hit speed, and it'll flash a distance. Let's use 70 miles. 70, enter. And we need to go that far in 27 minutes. So hours, 0, 27, enter. When you enter times, if the trailing digits are 0, then you don't have to push the zeros, you can just push enter. And it's saying that we need to fly about 156 to make it there on time. Let's push the flight button. And the distance flown is the first thing that flashes at us. So we'll go ahead and push enter on that. It wants our ground speed, so we'll put that in. Enter. Now it asks for our time. 19:21. Enter. And it spits out our distance flown. Any of these numbers look familiar? All right, so let's go to the next function in the flight menu. Arrow down to top of descent. We can put in our ground speed, which is still 155.6. Enter. Our initial altitude is 8,000. Enter. Our descent altitude will be 3,100 because that's the first segment of our approach. Enter. And it asks us for a rate of descent, so let's put in 700. Enter. And it tells us that the top of our descent is 18.2 miles from the start of our approach fix. And so we'll start down at 700 feet a minute when we get there. And back to the flight button. Arrow down to endurance. Enter. We input our fuel on board. 48. Enter. Our fuel burn. Let's change this from 11 to 9.8. Enter. And you can see that we can fly 4 hours and 53 minutes and 53 seconds with no reserve. Now, of course, for day VFR, we need to subtract 30 minutes from that, or 45 for night and IFR. Back to the flight function. Arrow down to leg time. Enter. Let's change this to 110. Enter. Our ground speed is dropped to 132 for this leg. Enter. And it's telling us that it'll take us 50 minutes to fly that leg. Let's work this flight button a little bit more, and let's go down to specific range, SPC range. Our fuel is down to 36 now, so 36, enter. Ground speed is 132, enter. Our fuel burn is 9.8, enter. And our specific range is almost 485 miles with no reserve. So back to the flight button one more time, and scroll down to FPH. Let's enter 32 for fuel, and for time, let's put 3:enter. And our fuel per hour is actually 10.7 under these conditions, so maybe we should have leaned it a bit more. Well, now that we're near our destination, we've got to get set up for the approach. So let's use our timer function. Timer. At 90 knots, this approach is 4 minutes and 20 seconds. So if there's something in there, we'll need to hit the convert button and then reset above timer. And then we'll need to hit 0:4:20. Remember, it's always hours, minutes, seconds. And then we can hit enter or timer, and that will start the clock. Hitting timer again will pause it. Timer again resumes. If you need to reset it to 0 in order to count up, press convert, timer, and then timer again. And the clock starts going up. Convert, timer resets it. If you needed to start counting down, Push the little minus button to let it run up a little ways, then press it again to let it run down the other way, hit it again to get it going the other way. Pressing timer at any time will pause the clock. The timer will continue to run while you're in other functions too. When it gets to 0 on its countdown, it's going to start flashing at you and then count up. And you better be landing or going missed at this point. Congratulations on your landing. You pull up to your fuel pump, but the darn thing's in liters. What the heck, huh? Where'd you go? Well, that's no big deal, because there are a lot of conversions here built into this computer. So if we need to buy 32 gallons and get it into liters, well, we put 32, convert, and then press the number 9. And it's 121.13 liters. But this thing won't convert currency, but that's okay. Your credit card will do the conversion at the pump. Conversions can be done within menus as well. If you're doing pressure and density altitudes, it's going to ask you for Celsius. And if you only have Fahrenheit, you can convert right inside the line that it's asking. Go into pressure density altitude. Field elevation here is 1632. The pressure is 30.14, and the temperature is 23 degrees Fahrenheit. On the temperature line, we're going to push 23, then convert, and then F to C. It's the little C button, coincidentally, and it changes to -5 Celsius. Pretty handy. We can hit enter and it spits out our pressure and density altitude for our new field elevation. Being able to do conversions right within the menus is really handy. And you can do math on each line as well, should you need to. This flight computer is pretty neat, and it can do a lot of things that the analog E6B cannot do. The only two things that irk me about this are the fact that everything's in calibrated airspeed instead of indicated airspeed, and it cannot do wind drift angle problems. Of course, the only time you probably need to do a wind drift angle problem is on a test, but this calculator is approved for the FAA test, and that's why I got it. I used it on my advanced ground instructor exam. But let's do a quick wind drift angle problem so you at least know how to do it. And this requires a little bit of knowledge of geometry. For instance, if you're 8 miles off course after flying 120 miles, what's your drift angle? And what's the correction angle you're going to need if you've got 60 miles to go? This is dumb anyway. I don't know why you're a whole 8 miles off course, but let's pretend that you are for some stupid reason. So we put in 8 divided by 120, and we get 0.0666. Now this is meaningless because it's in radians. So we need to multiply this by 57, because there's about 57 degrees in 1 radian. So you do need to remember this conversion. Actually, it's 180 over pi to be precise, but 57 is close enough. And it shows us that we've drifted 3.799 degrees. Let's call that 4. And so to find the correction to get back on course, we'll put 8 miles that were off course, divided by 60 miles left to go, then times 57 to get it back in degrees. And it's about 7.6. Let's call it 8. Plus the 4 that we've drifted means we need to turn 12 degrees to hit our target. Like I said, you'll probably never need to do this in real life because your GPS or your VOR are going to tell you how to get where you need to go. Well, now that we've been through the ins and outs of the Sporty's electronic E6B flight computer, hopefully you see that it's really not that difficult to use. It does come with this handy little reference card here and tells you the inputs and the outputs it's expecting, and that might be useful to you. But my goal with this video is to show you all the functions in the order that you're likely to use them in real life. I want you to feel comfortable using this on a test or in the air. Its ability to do math and weight and balance makes it all worth it, I think. As long as it's got a fresh set of batteries, I think it trumps the analog E6B hands down. Now, it doesn't have the cool factor that this one does, nor is it as reliable because of the batteries. But after watching this video, I hope that you feel comfortable using it and that you feel that this is the best instructional electronic E6B video out there. But please leave a comment down there if you've got other tips or tricks that you'd like to share with others. There will be a lot more aviation videos to come this year, so stay with me on 121.6. But go ahead and subscribe if you haven't already. I'm Mike Thompson, and thanks for watching. I really appreciate it.